Right, let's have a look at this question. Second moment of area. Calculate the second moment of area for the area enclosed between the curve y is equal to half x squared and the line y is equal to x with respect to first the x-axis, second the y-axis. What do we need to do first? We always, for this question 5, whether it's area, volume, centroid, second moment of area, moment of inertia, those are all the applications where we must, and fluid pressure, but these ones specifically, second moment of area and volume, centroids, you must see the picture. Right, so you must sketch the graph and draw your differential elements, your representative element. You need to check, draw it either perpendicular or parallel to the reference axis. So let's have a look at what we're going to deal with here. We got y is equal to half x squared and y is equal to x. These two graphs will intersect. We need to check the points of intersection. Let's work that out first and then sketch the graphs. Okay. So let's find the points of intersection. So here, let's call this y1, let's call this y2. So at the points of intersection, we equate y1 equal to y2 or x1 equal to x2. We will solve simultaneous equations. So y1 is equal to half x squared, and then y2 is equal to x. Be careful, do not divide by x, because if you divide by x, then you'll have half x is equal to 1, and you'll only have one point of intersection, you will lose the other point. So do not divide by x, make the equation equal to 0, because we have a quadratic here. So that's half x squared minus x equals to 0. If you wanted to, you could have plus multiplied by 2 first. Doesn't make a difference. Clearly now I can take out x as a common factor. So I'm left with half x minus 1. Alright, so now you can see I've got two factors here, not just one. So x is equal to 0 or half x minus 1 is equal to 0. So half x is equal to 1. Now I have to cross multiply by 2. 1 times 2 will be 2. So we have two x values. X is equal to 0, x is equal to 2. Now we need to find the corresponding y values. These are simultaneous equations. So we can substitute into any equation we want to. We know that y is equal to x. So I know that when x is equal to 0, y is also equal to 0. And then when x is equal to 2, since y is equal to x, y will also equal to 2. But now, you make sure, do not trust that your answer is correct, especially in the final exam. Don't think that you substituted into one equation and you got the corresponding values and you think that is correct. Check both equations. So now let's see. Where's the second equation? There's a here. If I put x is equal to 0 here, 0 squared is 0, 0 times half, 0. So that is correct, y is equal to 0. Let's substitute x is equal to 2. 2 squared is 4, 4 divided by 2 is 2. Did we get 2? Yes, we tested both equations. Now, we got our points of intersection, which are 0, 0, 2 and 2. Let's sketch the graph. we can use a table of values because this is half x squared and that is x. So this is just my xy axis. So if you want to get a proper graph, then you use a table for a parabola of this form, ax squared. So let's just use the table there. I've got x and then I've got y is equal to half x squared now. The points of intersection of these two curves lie in, basically you have one point which is 0, 0, the other point 2, 2. Are there any points which are negative here? There's no points which are negative. That means it is unnecessary to sketch the negative side. But if you want to, that's fine. Right. So what am I saying? Unnecessary, we know from 0 to the right is what we're dealing with. So let's go 0, 1, 2, 3, 4. Just a few values to get an idea of what's going on. So when x is equal to 0, 0 squared is 0, 0 divided by 2, 0. When x is equal to 1, 1 squared is 1, 1 divided by 2 is 1 over 2, which is 0, 5. When x is equal to 2, 2 squared is 4, 4 divided by 2 is 2. When x is equal to 3, 3 squared is 9, 9 divided by 2 is 4.5, 4, 5. When x is equal to 4, 4 squared is 16, 16 divided by 2, 8. So we got a few values there, you can see that. So let me just plug this and see. So I got my, say 1, 2, 3, 4 here. And then up, I'm going 8 up. That's 1, 2, 3, 4, 5, 6, 7, 8. Right, so we have an idea of what's going on here. So our first point, 0, 0. Let's plot it. So we have a 0, 0. What's our next point? 1, 0, 5. So there's 1 here. This is also 1, so 0, 5 may be somewhere around here. The next point is 2 and 2. When x is equal to 2, y is also equal to 2. So that is somewhere here. What's the next point? When x is equal to 3, y is equal to 4, 5. So there's 3, 1, 2, 3, 4, 4, 5 is here. So there's my point there. What's the next point? When x is equal to 4, y is equal to 8. 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6, 7, 8. Somewhere there. And we have half of that parabola. Remember, y is equal to ax squared. If a is a positive number, then this is your parabola. But now, we are only sketching this half on the positive side. Why are we doing that? Because it is unnecessary to sketch it on this side because there's no area on that side. Okay, so now all you do is join it up. So there's it, you join the dots there, and you come down. Right, you can carry on up this way. We don't need to sketch that. So that's one half of the parabola there. What about the other graph? The other one is easy because y is equal to x. So what do we know? When x is equal to 1, y is equal to 1. When x is equal to 2, y is equal to 2 there. When x is equal to 3, y is equal to 3. When x is equal to 4, y is equal to 4. So our point of intersection, we know, is here. We can see from the table. So there's our ruler here, and we sketch our straight line. And this part here is not even necessary, because according to my table I didn't even plot that point, make any negative value. Can you see that? So there's it, y is equal to x, and this is y is equal to 1 over 2 x squared. So here is the enclosed area. You know, for every single application here in chapter 5, you will be sketching the graph. So this point here is 0, 0. This point, we found it, it's even here too. When x is equal to 2, y is equal to 2. We already got it there. So that's a 2, 2. The area is this shaded area here. Let me just shade this whole area. That is the enclosed area. Now, let's redraw this area. So we know it's going this way, it's a straight line, and you have the parabola. So there is it, zoomed in, or we enlarged it. It's enlarged. So now, we need to make a choice. Do we use a perpendicular representative or differential element, or do we use a parallel differential element? So what do we do? It's your choice. If you are not told in the exam, then it's your choice. What's the first question? Calculate the second moment of area of this enclosed area with respect to the x-axis. Now, if I decide to use delta x as a breadth, my differential there is delta x, you can see that. Now, if I'm using delta x, then the top, okay, what did I call the straight line? I've already labeled it. I've called the straight line y2 then. So let me stick to that. So I call the top y2, the bottom y1. Right. Now, what do we need to work out? We need to work out the second moment of area with respect to the x-axis. So I made a choice. This is now perpendicular. So I know delta x, this differential element, delta x is perpendicular to the reference axis. It's perpendicular to the reference axis. So therefore, second moment of area is going to be given by the formula area times k squared. Okay, area times k squared, where k is equal to the length all divided by root 3. Right, so we use this formula if we are using a perpendicular representative rectangle or perpendicular differential element. Now, we are dealing with a top and a bottom. These are two different graphs here. Can you see that? Right. So, when we are working out area, it's the area of the top graph minus the area of the bottom graph. If we are working out volume, it will be the volume of the top graph minus the volume of the bottom graph. Same goes with second moment of area with the moment of inertia also. So second moment of area delta Ix is equal to the second moment of area of the top graph minus the second moment of area of the bottom graph. Okay, now, what is the formula for second moment of area? It is area times distance, or in this case, sorry, k squared. So now, what is the area of the top graph? Length times breadth, which is going to be y2. Okay, let me just write this down properly. This is going to be delta A, which is area, times k squared minus the area of the bottom graph times k squared. So what is area? Area is length times breadth. The length of the top graph going up is y2 and the bottom is y1. So area is length times breadth. That's going to be y2 times delta x. Delta x is your breadth times k, which is the length over root 3. The length is y2. So that's y2 over root 3 all squared. Area of the bottom graph, that's going to be y1, which is length times your breadth, which is delta x, and k, which is the length divided by root 3. It's the same length here, which is y1 all over root 3 all squared. So what happens here now? This becomes y2 times delta x. This becomes y2 squared over 3 minus y1 times delta x times y1 squared over 3. So y squared times y will give you y to the power 3. Right, so I'm going to simplify this. I'm going to take out 1 over 3 as my common factor there. Also, delta x as my common factor. What's common here is 1 over 3 and delta x. So now, that times that, y2 times y2 squared is y2 to the power 3 minus y1 to the power 3. So now this is the formula.
Is it necessary to write all that? Can we just like write 1 over 3?
Okay, the question is it necessary to write all that? No. You don't have to write all this here, but what I'm writing down now, this part here, delta I x, this is the second moment of area of only that representative rectangle. And now you write down total. So you must show this part here at least, and then your total now where you put in the integration sign. And there's my 1 over 3. And then we have our B and our A. And that's y2 to the power 3 minus y1 to the power 3. There's my dx. This formula is used, remember, only when your differential element is perpendicular to the reference axis. If it is parallel, then we do not use k, we use distance from the reference axis. Alright, so let's work it out now. From here, it shouldn't be difficult. What is y2? y2 has already been defined as the top graph. There's y2 here. y2 is the straight line. What's your b and a, by the way? By now you should know. If we are integrating with respect to the variable x, that means we need the x value at the beginning of the area and the x value at the end of this area. So let's substitute that. So that's going to be a2, 0, y2. What is y2? It's x to the power 3, y1. What is y1? y1 is the parabola, your bottom graph, which is 1 over 2, x squared, all raised to the power 3. We need to simplify that. Let me give you a minute to simplify this part of here. Make sure you apply your exponent law correctly here. Because if you do not apply your exponent law correctly here, obviously the final answer will be wrong. Alright, so you must simplify here first. So now, one more step before we integrate. So this is equal to 1 over 3, we got 2, 0. Well, x to the power 3 is x to the power 3. Here, we got 1 over 2 multiplied by x squared. This is multiplication. So exponent laws apply to multiplication and division. Okay. That means you can raise this 1 over 2 to the power 3. So 1 to the power 3 is 1. 2 to the power 3 is 8 times x. Now I'm not saying 2 to the power 3. This is not 2 to the power 3. It will be 2 times 3 because you have a power raised to a higher power. You multiply exponents. So 2 times 3 will be 6. And then from here, simple the integration. So that's going to be 1 over 3. Integrate there, integrate here. So that will be 3 plus 1, which is 4 over 4. Integrate x to the power 6, which is 7 over 7. And we're done. Just to use our calculator now. You got a final answer for me? Or are we working out individually? Let's work it out as it is. So we got 1 over 4 x to the power 4 minus 1 over 56 x to the power 7. Substituting 2 there, I get 12 over 7, so that's 1 over 3 times 12 over 7 minus, if I substitute a 0, I will get 0. You're clear with that? So 12 divided by 3 is 4, so that's 4 over 7 units to the power 4, which is 0, 5, 7, 1. So remember, there are two formulas to work out second moment of area. And now this is the formula that we use when it's perpendicular to the reference axis. If it was parallel, we would be using distance from the reference axis, not k. Alright, we continue next time.